Good morning, everyone, and welcome to the late August edition of the Southeast Monthly Climate Webinar, where we'll talk about climate and special topics pertaining to the Southeast region. I am Chip Conrad, the director of the NOAA Southeast Regional Climate Center, and I'll be giving a weather and climate overview. Our regular speakers today are Jeff Dober from the National Weather Service Southeast River Forecast Center, who will provide a water resources overview, and Pam Knox from the University of Georgia, who will give an agricultural impact update. And we will also be joined by our special guest, Morgan Thebo from the NOAA's National Integrated Heat Health Information System, NIAS, who will discuss climate and health in the Southeast. We thank everyone for joining us today. And just a reminder before we begin to type in your questions and comments in the question box, and we will answer them at the end of the presentations. Also, an email with a YouTube link to the recording, as well as a summary of today's webinar, will be sent out in the next day or two. Next. Okay, so let's start off with an overview of the last, basically the last 30 days. So this goes from July 23rd to August 21st, which would have gone through Sunday. Okay, and so we see here on the left, departures of the average temperature, and what we see is that there was a lot of variability. Temperatures were pretty close to normal. More of the area was slightly above normal, indicated by the yellows, especially the oranges. You see a few very small places where there are the reds, which is more than 3 degrees above normal. But you also see some greens and in Alabama, 2 very small areas of blue, indicating temperatures slightly below normal. In Puerto Rico, you see the map there on the right. Temperatures were pretty consistently about 1 degree above normal. Next. In terms of precipitation, as is typically the case in the summer across the Southeast, there's a lot of variability, but we do see pretty much a pretty broad trend that broad areas saw precipitation below normal. In some areas, some pockets much below normal, indicated by the oranges and particularly the reds. So this is tending towards the coast across much of the region. And then we tended to see heavier than normal precipitation amounts, especially up in Virginia, small parts of western North Carolina, very small parts of Georgia, and also parts of Alabama and a little bit of the western panhandle of Florida there. And over in Puerto Rico, basically precipitation was below normal. And this all relates to the persistent dryness that we've seen in the subtropical Atlantic, which I'll talk about here in a second. Next. In terms of precipitation ranks, and this is basically season to date. This is meteorological season, July 1st, going all the way up, and I believe this was through Sunday. And we see that broad parts of the area saw precipitation ranks that are, you see there in the white there, that are more or less in the normal range, but we see interdigitated there, a few places that were exceptionally wet, and a few places that even had record wetness. I think those places were just outside of the Southeast region. And we see a few places that were exceptionally dry. But by and large, precipitation didn't depart a whole lot from normal, except in a few localized spots. If anything, precipitation trended a little bit on the dry side, really towards the coastal areas, and a little bit tending to the wet side as we go towards the mountains. Next slide. In terms of severe weather, just want to show this in the month of August, climatologically, the occurrence of severe weather really goes down. We're talking about strong winds, large hail, and tornadoes. This is largely strong winds. And so we see a big decrease during the month of August, and the very last image here shows what it will look like here as we go into early September. So fortunately, our severe weather season in terms of thunderstorms is really winding down. Next slide. Well, unfortunately, this summer, the Southeast has really stood out in terms of lightning deaths. And so 10 out of the 14 lightning deaths that you can see there in the table happened across the broader Southeast. So this includes the District of Columbia and Maryland. And probably a lot of you heard about the tragic incident that occurred very close to the White House. There were 3 people that were under a tree that basically were struck there by lightning. And looking at the histogram there in the upper right, you can see there July is very much the peak month in terms of lightning deaths. Goes down markedly in August, then goes down markedly more in September. So again, the season is really wrapping up. Not having said that, of course, you can still get a lot of lightning, particularly down in Florida and parts of South Georgia and South Alabama this time of the year. Next slide. Okay, in terms of the tropics, it's very interesting. We are on a streak here in terms of the length of time between named tropical systems in the Atlantic Basin. We've gone 51 days since we had Colin, which was it's a very minimal tropical system. And so we're in second place here between 1999. This, by the way, is a record that goes back to 1995, but an impressively long time and really somewhat surprising given that we have La Nina conditions happening in the tropical Pacific, which correlates pretty strongly with above normal activity in the Atlantic Basin. Next slide. And so I put this image here to sort of illustrate what was going on. And if you were on the call last time, Pam Knox talked a bit about this, and this pattern is continuing. We've had anomalously strong winds out of the Northeast coming out of Africa. So you see the big black arrow there. And so those winds have been blowing a lot of dry air and also dust. And some of that dust at times has actually gotten into the southeastern US. This is an image from yesterday. And this flow is continuing here. And basically, the dry air really inhibits tropical development. It relies obviously on there being a lot of moisture in the atmosphere. And then when you have that persistent dust, that slightly reduces the amount of solar radiation hitting the ocean surface. And so indeed, I don't show it here, but there's an area there in which the sea surface temperatures are slightly below normal, which is unusual given climate change, and we typically see broad swaths of the Atlantic anymore in which sea surface temperatures are above normal. So that's really inhibited activity, but if we go and we look at other areas like the Gulf of Mexico, sea surface temperatures there are a bit above normal and the air is not so dry. So this doesn't mean, that we can't have tropical systems anywhere, but it has been putting the kibosh, as it were, on Cape Verde storms, which really start to develop off the coast of Africa. Next slide. And so here's the depiction. This is from yesterday, and this hasn't really changed. They've been looking across the entire Atlantic Basin. They've only been looking at one system, and right now it only has a 20% chance of developing over the next 3 to 5 days. It's moving westward, and it's going into that area of dry air. So this pattern persists here, and so it's going to be very interesting to see what happens the next couple of weeks. Next slide. And so this sort of shows it here. You see the peak in tropical cyclone activity basically at the very end of August, going in through much of September. So we're going into the peak time there, and this too is the time in which Cape Verde storms really start to enter the mix a whole lot. And so we'll have to watch things here very, very closely to see what happens. Next slide. Okay, and so in terms of El Niños, looking kind of into the future here, we're currently in La Nina conditions, okay? And this plot here shows that probability as we go into the future. So the JAS there is July, August, September, and then you see ASO, of course, August, September, October, and so forth. And so you see the blue bars indicating a high probability of continued La Nina conditions as we go through the hurricane season. And that's why NOAA is still thinking we're going to see above normal number of systems. But of course, that's going to be dependent a bit on whether those anomalously strong northeasterly winds start to abate there in the eastern Atlantic. But at any rate, we see those probabilities then trending down for La Nina as we go through the fall and into the winter months. They get to be less than 50% as we're going into the new year. And so we see the increasing probability of neutral ENSO conditions in the equatorial Pacific as we go into the winter, and a very slight increase in the probability of an emerging El Nino as we go into the new year. Next slide. Drought monitor, well, fortunately, there's not a whole lot to talk about. We see some areas there of yellow, of D0 that are abnormally dry. There's a few very small patches of moderate drought. So really not much to say there. It's been on the dry side over the last month. We're going to have to watch this very closely. And of course, this is going to depend upon tropical cyclone activity, if we get it or not. And climatologically speaking, if we don't get any landfalling systems, we could, with these conditions, if we don't get significant wetness, we could end up in some significant drought as we head into the fall. We'll have to wait and see. Next slide. And so this just sort of shows it here, just again for the southeast here. Next slide. And so in terms of the drought outlook, there's not much to report. The very small patches there of D1. Right now, the thought is that it's going to remain or it might improve. And I think some of that improvement might relate to the fact that we have above normal tropical cyclone activity predicted over the next month. Next slide. In terms of the next 3 months, basically, temperatures are expected to be a bit above normal. Okay, so basically here, 33 to 40% chance of above normal temperatures. And in terms of precipitation, we really have kind of a gradient or a change that basically across northern Alabama, northern Georgia, western North Carolina, and southwest Virginia, there's a slight probability of below normal precipitation, nearly equal chances across much of the region, and then and leaning towards above normal precipitation across Florida, and also basically North Carolina there. Next slide. Okay, and over the next 6 to 10 days, basically the temperatures are expected to be over parts of the region slightly a bit above normal. And then if we look at precipitation, there's a broad swath in which there's a slight lean towards above normal precipitation. And then in Florida and parts of the Gulf Coast, it's leaning towards near normal. Next slide. And so for the rest of the week, so this is the next 24 hours. Most of the area looks like, just a probability of, for the most part, afternoon and evening thunder showers, pretty light and scattered. And then over the next 7 days, and I've noticed the trend here in these forecasts, it seems like it's trending farther and farther south, that significant precipitation there indicated by the reds going into the oranges there is going to be largely confined to Alabama, parts of southern Georgia, and much of Florida there. Next slide. Okay, so just a quick summary. So in terms of temperatures over the last 30 days, they've been slightly above normal across much of the region, slightly below normal across western Georgia, southern Alabama, and the Florida Panhandle. For precipitation, it's been slightly to much below average in most areas, but above average in central to western Virginia, portions of northwest North Carolina, southern Alabama, and the Florida Panhandle. And basically, in terms of the hurricane situation, the hurricane drought, as it were, is expected to continue in the short run, but likely to pick up the next few weeks, obviously, as we're going into the core of the hurricane season. There's a slight chance of tropical cyclone development over the next days for a tropical wave located near the Cape Verde Islands, and it's actually now a little bit west of there. Drought, just a few pockets of abnormally dry, D0, moderate drought across the region, with severe drought across Puerto Rico and Virgin Islands. So I didn't mention that, and again, that relates to all that dry air coming off the Saharan desert. But that's expected to improve. Hopefully it will when we get tropical cyclones, and hopefully they won't be that strong. In terms of the outlook, basically for the next week, leaning towards warmer than normal across the region, precipitation leaning towards above normal for most of the region, except for much of Florida and Gulf Coast, where near normal conditions are expected. Over the next 3 months, temperatures leaning towards warmer than normal across the region, precipitation leaning to drier than normal in northern Alabama, Georgia, western North Carolina, Western Virginia, and leaning towards wetter than Florida and the coastal Carolinas. Okay, and with that, I'll turn it over to Jeff.
Well, Jeff was not able to join us today, so this is Todd Hamill from the Southeast River Forecast Center, and so I'll start with our 28-day average stream flow, and what you see here is that for much of the summer, going into May and so forth, we were really starting to lean in towards drought in overall in the Southeast, and as we got into May, we've had opportune rain through the Southeast, so that we haven't really gone into drought. We were really showing, as he showed the drought monitor just a little bit ago, we're only showing a little bit of D1. Most of it is just abnormal dryness, and that's reflected in our rivers also. We've had enough rain to keep water in the system and moving through the system, not everywhere, but in a lot of places, and it's kind of kept us out of drought. And the areas where we are concerned more about drought are in North Carolina and in South Carolina. But we'll take a closer look at each of the states. We'll go ahead and look at the at our next one, next slide, which will start off in the South, and we'll start in Alabama. And you can see that Alabama's been in really pretty good shape. Again, earlier in the summer, we were really starting to dry out some, but we've had enough rain through the period with afternoon showers and thunderstorms and periodic storms. They've been daily and they've continued. And I think that with all the moisture across the Southeast, that they have been very productive in producing runoff, and rivers have responded to that. So they are one that we're decreasing very quickly as we went through the spring. And then as we entered summer, we started to get that convective rainfall, and that has helped conditions there through the Southeast. So even though we have not really had much flooding, we've had a little bit of flooding, and we'll talk about that in just a little bit, but we've had just a little bit of flooding in Alabama, but for the most part, it's been without flooding. In Georgia, some of the same thing. Earlier in the summer, we started to see drought come in. We started to see the river start to come down a lot, but that has changed. That turned sometime in the late June and early July timeframe as we started to get some heavier rain across Georgia, and that has helped things in general across Georgia. With the southeast corner probably not getting quite as much, but otherwise we're in good shape. And then in Florida, the south of Florida has had more problems. They've been a little bit drier than normal. We don't have as many rivers down in that area, so it's probably not as representative of the whole of Florida, but we have had a lot of rain in the Panhandle, and enough rain in the Panhandle and a little bit in the northern part of Florida near the Jacksonville area, and that's kept things kind of wet enough that we're near normal for the state. So let's go ahead and move a little further north and check our South Carolina. South Carolina has also had the same pattern as the rest of the Southeast, in that we really started to dry out in that May timeframe, which is not unusual, and we started to dry out and then stayed kind of dry during that time. But again, we had enough rainfall in the month of July, and almost into early August, that we improved conditions across much of that area. And as I mentioned before, there are still some parts now of South Carolina and rivers that are running from the drier part of North Carolina into South Carolina that are affecting those stream flows. So we are starting to, it's one of the areas that's starting to show some effects of the dryness, but we've had just enough rain that the drought monitor with respect to agriculture and everything else just hasn't quite got there. This is a lagging factor, the rivers are, and but we are starting to see it creep in, and that soils are drying up and rivers are drying up, that we are starting to see a few problems. North Carolina, very similar. They had some rain early in the June timeframe, which helped them, and then they've kind of gone back and forth where they dried out. They've gotten a little bit more rain and improved, but this is the time of the year when even normal rainfall will not keep those rivers up enough. Normal rainfall is not enough to keep us from getting drier in some of those areas, and that's why a lot of the reservoirs will tend to be falling this time of year and so forth. So we're not in as good a shape in North Carolina either, but in Virginia we have gotten. Now, the Southeast River Forecast Center only covers part of Virginia, and this is the whole of Virginia, but we have seen enough rainfall that we're almost in the above normal category in some places in Virginia. So let's go ahead and move on, and we'll talk about what's going on right now in the Southeast. And one of the things you'll notice, and you know, for it seemed like for years, we always had something in flood. We always had somewhere across the Southeast that's been in flood. Well, over this past summer, from May probably through now, we've had very, very few points go into flood. We have had some action stages, and probably the most active area is in the panhandle of Florida and South Alabama. As we continue to get rainfall from the Gulf, sea breeze type thunderstorms that flare up pretty much continually each day across that region. So most of it's been pop-up thunderstorms and keeping things very, at least somewhat wet. The rest of the area, we have seen very little flooding, but again, we've seen enough rain that has kept the rivers from not getting too low for this time of year. So let's go ahead and move on to the next slide. So why is that? So this is the time of year where we're starting to ramp up again. We're in week 34 of our year. And we always, again, I should always talk about this. You can potentially have a flood, minor river flooding and damaging river flooding any time of the year. But we're also getting into the time of the year where it's feast or famine. We're either pretty dry during this time of year, beautiful weather to be outside as we get into fall and things start to dry out some. So you're either dry or the tropics are hot and do bring us rainfall in the Southeast. And that rainfall is part of our climatology, and it's very important to get at least some from tropical rainfall. We've been under a tropical air mass, and it's kept things wet over most of the Southeast, and that's with our pop-up thunderstorms. But we've really avoided the hurricanes and the tropical systems, which is kind of nice. So we're in a good spot, but we'll see how that translates as we get into the peak of the hurricane season. And you can see as we get to between 35 and 41 here, weeks 41, that's when we expect the potentially heaviest rains due to the tropical season, and that gets to the peak of our hurricane season. The peak of our hurricane season is right around September 15th, somewhere in that 15th to 18th time frame. So we're still about 3 to 4 weeks away from that. So we'll be watching the tropics because this is the time we would expect that. So let's go ahead and move on. That's the Southeast River forecast. So I want to emphasize here, this is Florida. So Florida has a little different climatology than the rest of the Southeast, and this kind of is their flood season. When we look at the rest of the Southeast outside of Florida, we look at the winter where we've lost leaves on the trees, we get, and so runoff comes much easier. For Florida, this is when we get afternoon showers and thunderstorms all the time, and then on top of that, we get tropical weather in the Southeast. And so a lot of times we can expect a lot of our flooding, our major flooding, and widespread during the next 6 to 8 weeks. And again, it's very related to how much tropical weather we're going to get. And right now, even through the models hinting at it and so forth, and Chip kind of talked about it too, things really look quiet through Labor Day, which gets us close to our peak hurricane season. So we'll just have to see. It can flip very quickly. So I don't want to jump the gun here, but hopefully maybe we will still see enough rainfall to keep us at a drought, but not necessarily have any tropical systems to cause any problems. So let's go ahead and move on to the next slide. So overall, and this is for the autumn, September, October, November for us, we're looking for normal risk for river flooding. With all the rivers kind of just above being below normal. So they're near normal, but they're on the low side of that, where that will help us if we do end up getting an active hurricane season. Because with an active hurricane season, the potential for rainfall moving into the area and causing some flooding across the southeast is there. And and part of that, with the potential for an active hurricane season, we kind of look at the at Florida as still a high risk for that reason. Their rivers are running, near normal for the most part, but slightly just below normal. So again, those are the things that we're watching. Once we get a tropical system in here, there's not a whole lot of predictability about that, or where they'll go. But overall, it looks like, just because of our stream flows the way they are, we're looking at low risk of flooding for the southeast. So let's go ahead and move on to the last slide. And this is just a summary, and we talked about most of this. Just the 28-day USGS stream flows, they're near normal over most of the southeast except for the Carolinas and the Florida Peninsula, where stream flow is below normal. And then stream flows typically fall off this time of year. And again, that's with the exception of Florida. And expect stream flows to continue mostly in that range, especially if we continue with the rainfall. You even look over the next week, we continue to have rainfall even without tropical activity. If we do add tropical activity, that will change things also. And then flooding will be typical, which means a low chance for interior southeast river systems, an increased risk across the Florida Peninsula with the risks of tropical systems. And we'll go ahead and go on to the next slide. Now we'll go to Pam.
All right, well, thank you, Todd, and good morning, everyone, and welcome to the heart of the growing season. If you're in your grocery store, you probably see a lot of local crops that are showing up there. I got some Georgia peaches earlier this week in the grocery store. And of course, the commodity crops like peanuts and cotton are all doing great guns. A lot of the corn's being harvested already if it hasn't been. But cotton bolls are starting to show up, and peanuts are starting to develop as well. Early peanuts are being harvested. Some of my friends have been posting pictures of boiled peanuts online, and so definitely that time of year, and make sure that you go out and support the farmers. So let's jump right in so we give time for Morgan. One of the things that really struck me this year was that the minimum temperatures have been ranked in the top 10 in many parts of the southeast. You can see there the orange, the reds and the dark reds are ranked in the top 5. The oranges are in the top 5 to 10. Those warm overnight temperatures have had some problems for producers. For one thing, livestock are more stressed when it's hot at night because they can't cool off, just like humans. We're all mammals. Another thing that's affected is the corn yield. I put a little inset there because most of you probably don't know, and I have learned this over time. If you have dry conditions in the spring, then you don't get pollinated kernels, and the ends of the ears don't really show any kernels. But if you have dry conditions, or if you have hot nights later in the season, the kernels that are there just don't really fill out. The sugar doesn't reach that far into the crop. And in either case, you lose a lot of yield because you're just not having the full ears. And so that's one of the things that I've seen reported in a number of places this year. Let's go on and look at soil temperature and moisture. It's not surprising soil temperatures are maybe a little above normal in a lot of the southeast. There's an area down in the southwest part of Georgia and the Panhandle, and then on over into southern Alabama that are quite wet, and that's keeping the temperatures down. Very different compared to the western part of the U.S. And soil moisture generally has been quite good because we've had these more frequent rains, at least since the beginning of July. And so most places are not seeing problems with soils that are too dry. In fact, if anything, a lot of places it's too wet and they're having trouble getting into the fields, which is really important this year because it's been so wet, we're seeing a lot of problems with diseases. So if we go on, some of the recent conditions that we've seen, because of all the high humidity and the frequent rainfall, the fungal diseases continue to be a huge concern for many different crops. And so that's a problem because you have to go out and spray, and if you can't get into the fields, then you get behind on that, and that makes things worse. The rainfall has improved pastures quite a bit. There's not too many farmers that are feeding hay at this point. They're trying to put aside hay for next winter, but if it's wet, then it's hard to get that hay dry, and so that's still a problem for some producers. Peaches are nearly all harvested. I think in general there were pretty good yields, except for the early blooming varieties that got hit by that frost in mid-March. But the later varieties did better, as the same with blueberries and apples. And so things are looking a little better than they thought they might be earlier in the season. A lot of the corn and other grains that are being harvested are showing more signs of aflatoxin and other molds than usual. So farmers that are growing those crops have to be very careful about moisture levels when they harvest the grain and then drying them out in a timely way. So that's something that really people have to keep in mind. And then soybeans have been doing great guns this year. They're ahead of the long-term average conditions. A lot of them are getting pods on now. And so those have been doing quite well. If we go on, you skipped the condition monitoring. There we go. Condition monitoring reports have died down quite a bit from our flash drought in June. Some people are still sending them in. I don't know what they're doing out in Arkansas, but man, they've really gotten a lot of reports from Arkansas. Of course, it's a lot drier there as well. But it's good to have condition monitoring reports from the Southeast, even if we're not in a drought, because it does help the drought monitors figure out where dry conditions still exist. And so keep that in mind. You can still do that. And if you do it every month, that would be even better. If we go on, just looking ahead for the next few weeks, and Chip already mentioned this, a lot of rain is expected in most of the region. It'll probably be the driest in Virginia and North Carolina and inland areas of South Carolina. It's farthest away from that kind of more or less stationary front that's draped across a lot of the region. That front is really serving as the focus for a lot of these daily thunderstorms. And so this is not tropical rain. This is just rain from daily thunderstorms as much as anything. I looked at the tropical tidbits to see when we would get 24-hour dry spells, which farmers need to get into the fields. And a lot of the places, there really are no 24-hour dry spells. Now, during those spotty thunderstorms, not everywhere is going to get hit, but you don't necessarily know if it's going to be your area or not, because those thunderstorms are so scattered. It does look like we're going to see warmer than normal conditions continue, so there's going to be, with all that rain, you can bet there's going to be a lot of humidity, and the chance of more fungal diseases is going to continue. And if you look at the tropics, the models that look at the long-range tropical outlooks are starting to pop up all these little storms. And you have to always be careful this time of year. If you're looking at something that's 10 days out, you don't have a lot of trust in it. But the fact that more than one of the models is now starting to show these areas that could develop into tropical cyclones is something to keep in mind. We're definitely going into a different pattern, and so that's something that we'll have to watch with more intensity as the next few weeks go by. So if we go on. All right, just my summary here, and then we'll get to Morgan in just a minute. Nearly all the drought is gone, and just a few areas of abnormally dry conditions, and even those are pretty scattered. And I don't think that's going to change anytime soon. Rain and high humidity has really increased the incidence of fungal diseases and moldy grain. So that's something that farmers are watching carefully. Next few weeks look like they'll be continued warm and probably rainy with spotty rain. Not a whole lot of areas of dry conditions, except maybe in the northern part of the region. And so that's going to cause some problems with boll rot and cotton and other kind of crop diseases as well, mold and white mold and so on. The tropics are starting to show some increased chance of activity. I don't think anything's going to happen in the next week, but something to start watching a little bit more carefully as we go into the peak of the season. And so with that, I will pass it on to our guest speaker, Morgan.
Thank you so much, Pam. Good morning, everyone. It is a pleasure to be speaking with you all today. My name is Morgan Szabo, and I'm the Climate Health Communications and Outreach Coordinator with NOAA's Climate Program Office. I'm going to be presenting today on climate, heat in the Southeast with a focus on recapping the summer, looking ahead at future heat, and looking at ways that the government is addressing extreme heat and solutions for a cooler nation. I want to first start off talking about the impacts of extreme heat. Extreme heat kills more Americans each year than any other weather-related event. And it is also referred to as the silent killer because we do not see the impacts as clearly as a hurricane or tornado. In addition to the hundreds of annual deaths and thousands of ER visits as a result of heat-related illnesses, heat has additional societal impacts as well. Extreme heat can have huge economic impacts, including billions of dollars in productivity losses, losses in agriculture from livestock and crop yields, and much more. Extreme heat has caused damages to infrastructure, including buckling roadways, down power lines, and the impacts to the very nature of the environment. And people are starting to pay attention to this national problem, as extreme heat made headlines across the country this summer, especially in the Southeast. Many states across the country broke temperature records, experienced multi-day heat waves, and with some facing compounding hazards, including drought, wildfires, and flooding. And climate projections indicate temperatures will continue to rise in many communities across the country, which means Americans will continue to face extreme temperatures more frequently and for longer periods of time. In looking more closely at this summer in the Southeast, we're going to look back at the past 3 months. NOAA's National Center for Environmental Information puts together climate summaries for each month, which can easily be accessed on climate.gov. The average temperature of the contiguous US in May was 61.9 degrees Fahrenheit, which is 1.7 degrees Fahrenheit above average, ranking in the warmest third of the 128-year record. While temperatures across the Northwest and Northern Rockies were below average, much of the Deep South and locations east of the Mississippi River were above average, and triple-digit heat scorched portions of the South throughout the month. June 2022 ranked the 15th warmest in the 128-year period of record, and temperatures across the Southeast were above average or much above average, such as in Georgia and Florida, which experienced a top 10 warmest June. It is important to note too that during June 2022, the contiguous US average minimum nighttime temperature was 2.2 degrees Fahrenheit above the 20th century average, ranking the 7th warmest on record. This is a startling ranking as higher nighttime temperatures mean that the body is not able to cool off from the day and can disrupt sleep and increase heat-related illnesses. Now moving into July. July 2021 was the hottest month ever recorded. July is typically the world's warmest month of the year, and this July was no exception. As you can see, nearly the entire country was warmer than average. July 2022 was the 3rd warmest July ever recorded, and 7 states across the US had a top 5 warmest July on record. On July 20th alone, 46% of people in the US were under an active heat advisory, watch, or warning. Several heat waves with daytime temperatures over 100 degrees Fahrenheit occurred across much of the US during July, contributing to record energy demand and heat-related illnesses. And speaking of heat-related illnesses, NOAA and CDC worked to develop a heat and health tracker to provide local heat and health information so communities can better prepare for and respond to extreme heat events. The image on the left is a snapshot of the heat-related illness and temperature map, which shows the rate of emergency department visits associated with heat-related illness per 100,000 ED visits during the week of June 12th through 18th this year. This particular week is chosen here to show the highest rate of ED visits in the Southeast from the beginning of May up until this last week. And during the week of June 12th, most of the Southeast experienced temperatures at 90 to 100 degrees Fahrenheit. Therefore, it's imperative that we address extreme heat in communities to prevent heat-related illnesses and death. And you can view this heat and health tracker on the CDC website or by going to heat.gov. Additionally, counties in the US are experiencing a top 10 warm year maximum temperature in 2022, along with a social vulnerability index of greater than 0.75 with a scale that goes from 0 to 1. Counties in the Southeast are highlighted here, including prominently in Georgia, Florida, and Alabama, and South Carolina. This data from our colleagues at NCEI and CDC indicates that counties in the Southeast are highly vulnerable to extreme heat, especially when paired with underlying and social economic vulnerabilities, including but not limited to poverty, lack of vehicle access, and crowded housing. And Chip has already covered the monthly and 3-month outlook for you all, so I'm going to slip this slide, but I did want to mention that these seasonal outlooks are used in a climate and health product that I will touch on later in the presentation, but can be used to help prepare decision makers to protect their citizens. And this is especially important looking ahead, as people can still experience heat-related illnesses at the end of the heat season. And in addition to looking ahead at the next few months, I also wanted to take a moment to look at climate projections to show how hot it could be in the future in the Southeast. On the screen, you can see the historical climate as well as the climate projections for Pinellas County, Florida, where St. Petersburg is located. And from 1960 to 1990, the county experienced an average of about 64 days of extreme heat, which we're defining here as 90 degrees or above. Under the RCP 8.5, the highest emission scenario, referred to as business as usual, the likely outcome if society doesn't make any efforts to cut greenhouse gas emissions, shows that the county could see almost 150 days above 90 degrees by 2050, and we could see 195 days above 90 degrees by 2090. That's 53% of the calendar year that the population of that county could be experiencing extreme heat. And this could lead to severe societal and economic consequences, including high levels of heat-related illness and death. And I included a second projection here of Jefferson County, Alabama, where Birmingham is located, to show that this is not an isolated projection, that many counties across the Southeast will continue to be highly impacted by extreme heat now and in the coming decades. So you may be asking, why is extreme heat an issue? Or why is extreme heat not talked about more? And there are many reasons for that. Extreme heat is an overlooked issue from the mere fact that the impacts are invisible, as it's not immediately destructive as a hurricane or tornado. The impacts may be delayed and over time buckling on railroads from heat, and the impacts are hard to quantify. Additionally, extreme heat is not one particular agency's to focus on, and extreme heat is not a climate disaster covered under FEMA's Stafford Act. And while everyone is at risk of extreme heat, some groups are more vulnerable to heat-related illnesses than others. For instance, outdoor workers and athletes are at a greater risk than office workers because they have increased exposure to heat. Other groups may be more disproportionately affected by the effects of high heat as a result of age or poor health, or lack of resources that enable them to adapt or recover, such as people experiencing homelessness, incarcerated people, low-income communities, and more. And of course, in many instances, we wait too long to prepare for these events and are not ready for when heat waves do strike. For many years, many federal agencies worked separately on components of extreme heat. But to better serve the American people on this issue and provide a coordinated federal response, NOAA and CDC launched the National Integrated Heat Health Information System, or NIHIS, in 2015 to develop and provide actionable science-based information to help protect the nation from heat. And NIHIS spans many agency missions and mandates to deliver solutions faster and more efficiently, and you can see a list of our partner agencies at the bottom of the slide. NIHIS consists of an interagency working group, as well as a partner network that allows us to engage with our state, local, tribal, NGO, and academic partners, as well as international partnerships. And extreme heat needs to be addressed across all timescales, from warning issues from the National Weather Service to decadal long-term planning to protect citizens now and in the future. And through the NIHIS program, we work with federal agencies as well as I mentioned, state, local governments, and more to develop decision support services to address the planning, preparing, response, and recovery for extreme heat. And for more information about preparing your community for extreme heat at all timescales, you can visit heat.gov and click on the planning and preparing page. And NIHIS has many different working groups and projects, with two that I really want to address here. So the first is that NIHIS has a communications group working together to develop targeted messages to convey the issue of extreme heat to the public. And as I said earlier, heat is the silent killer. So getting the word out about heat, not just the signs and symptoms of heat illness or to let people know they're being impacted today, but to also educate people on actions they can take now and proactively to prevent heat illness for themselves and in their community. And in some cases, simply increasing awareness of the risks that extreme heat poses to health can encourage people to take adaptive actions, such as going indoors or getting to a cooling center. And NIHIS held 2 major social media campaigns this summer to educate the public. And you can view the posts and messages on our Twitter page or by visiting heat.gov, to search the hashtags NIHUS and hashtag heat safety if there's any messages and graphics that you want to implement in your community. But another major program I want to mention here is our urban heat island mapping campaigns. In this program, we're examining the urban heat island effect, which is that cities are typically much warmer than nearby rural areas, especially during the summer, as cities' roads and buildings gain heat during the day and radiate that heat into the surrounding air, which can lead to cities being 15 to 20 degrees Fahrenheit warmer than areas with more green spaces. And to learn where action is needed to protect vulnerable populations down in the future, NIHUS and partners launched these community-led campaigns to map the hottest parts of cities. Roughly 80% of Americans who live in cities can experience extreme heat variations across neighborhoods. And through this program, we work with communities to address solutions that can be implemented based on the data results. And just to give a quick overview, the UHI effect, as I said, has been studied for decades. So we know the basics of what causes it, and we know what can be done to address it, such as increasing reflectivity of surfaces so heat's not trapped, increasing green space, and so much more. And there are nationwide land surface temperature urban heat island efforts, but land surface temperature is only one measurable component of the heat island effect. But land surface temperature does not represent the human experience of heat, which also needs to look at air temperature, humidity, wind, and more. And our mapping campaign looks to improve methods for measuring, monitoring, and modeling urban heat islands. And it's also important that ours is a citizen science field campaign. Additionally, elevated temperatures with urban heat islands affect a community's quality of life and can adversely impact both the natural and built environments. And adverse impacts include compromised human health and comfort with increased risk of respiratory illnesses, heat stroke and heat-related mortality, increased energy consumption needed to air-condition homes and buildings. And additionally, a nationwide study found that neighborhoods subjected to historical redlining typically lack green space and suffer most from urban heat islands. And the study found that 94% of formerly redlined areas, which remain mostly lower income communities of color, are exposed to higher temperatures than non-redlined effluent areas. And on the right, you can see an image of Manhattan, with the darker squares are indicating disadvantaged communities that are marginalized, underserved, and overburdened by environmental factors. And next to that image is a heat map of our UHI campaign mapping Manhattan. And as you can see, the hottest parts of the cities line up with where the disadvantaged communities are also located. Therefore, this mapping campaign is able to identify hottest and most vulnerable neighborhoods in these communities in hopes that those communities will implement solutions to protect those populations. And we've been running our Urban Heat Island campaign program since 2017, with our first city being Richmond, Virginia. Since then, we've mapped 70 communities across the country, including this year's group of campaign cities. And we'll also be mapping 2 international cities later this year for the first time. And we've mapped a good deal of southeastern cities, including Richmond, Virginia, Atlanta, Georgia, cities throughout Virginia, Miami, West Palm Beach, and more. And the data reports and findings from the campaign are all open source and available on heat.gov on our Urban Heat Islands tab. And since this is a Southeast focus, I wanted to bring attention to 3 of our previously mapped southeastern cities to show the mapping results and also showcase how cities have used the results to implement solutions. And first up is Charleston, South Carolina, which conducted its mapping campaign in the summer of 2021. By looking at this map, you can see the southwestern parts of the city are cooler than the northeastern parts of Charleston. And initial findings found a 11.8 degree Fahrenheit temperature differential across the city, and also found a 1.9 degree Fahrenheit average evening temperature anomaly of disadvantaged versus non-disadvantaged communities. And in observing the distribution of heat across the region, researchers found that in neighborhoods with lower tree canopy, heat can concentrate throughout the day, keeping residents at higher heat health risk. Additionally, the dense industrial and commercial areas with significant amount of impervious surfaces can absorb and retain the heat throughout the day and nighttime. But on the positive side, they did find that the conserved forests appear to help reduce the concentration of heat amongst the densely packed single-family residential neighborhoods. And in regards to solutions based on this data, the organizers plan to integrate it into the city planning decisions and use it to engage citizens on extreme heat risks and mitigation strategies in urban areas. And next up is Raleigh and Durham, North Carolina. So this campaign also took place last summer, and the initial data found a 10.4 temperature differential across the mapping area. There were several observations of how the distribution of heat across the region varied, including forested parks help surrounding residential neighborhoods stay cool, especially those that feature the dense canopy layer. They also found large amounts of asphalt in commercial areas that can spill concentrated heat into the surrounding residential areas that lack protective vegetative buffers. And the densely packed suburban neighborhoods with high amounts of impervious surfaces concentrate heat throughout the day and night. And as mentioned, the data report found the large spaces of asphalt that increase the temperatures of the surrounding residential areas compared to neighborhoods with more greenery. And to combat the urban heat, Raleigh City Council authorized $70,000 to treat over 150,000 square yards of streets in heat island areas based on this mapping project. And the city will be treating pavement with titanium dioxide, which can reflect more solar rays and reduce the localized heat effects. And finally, Atlanta, Georgia conducted its mapping campaign last summer as well. Findings from the report indicated a 14.5 temperature difference across the mapping area, with the hottest parts in the center of the city. And like Raleigh-Durham, initial observations found large amounts of asphalt in the commercial areas, also found areas with expansive amounts of impervious surfaces absorbing and re-emitting heat. But on the positive side, did find that Atlanta's lush tree canopy does help to keep many of its single-family residence area cooler. And Atlanta has expanded on our UHI campaign and conducted independent studies to assess urban heat in all seasons through its Urban Heat ATL campaign, which can be viewed on its website. And we are in the process of finishing up the mapping campaigns for this summer, and the data reports will be released later this fall. And southeastern cities that have performed heat mapping campaigns this summer include Nashville and Knoxville, Tennessee, Columbia, South Carolina, and Jacksonville, Florida. And you can see pictures and media coverage of the campaign by visiting heat.gov or searching #UrbanHeatMaps2022 on Twitter. And just to quickly relate, so with 5 years of mapping, we've had many different types of outcomes and solutions for the data, which you can see on the left, including that Houston implemented the data into its resilience strategy. Honolulu was able to implement 10,000 trees by targeting tree planting based on the data, and much more. And I know we only have 1 or 2 minutes left, so just wanted to provide on slide that there is a lot that can be done with urban heat islands. And to learn more, again, you can go to heat.gov on our Urban Heat Islands page to be able to access more information about what can be done. And also just wanted to add some information here that more work is also being done in the southeastern region with some climate and equity pilots building off of climate and equities roundtables hosted last year. And there will be 2 occurring in Charleston, South Carolina, as well as Miami, Florida, with each pilot project a little bit different based on the community and factors the community face. So for example, Charleston will be examining the Gadsden Green community and measuring heat throughout the exterior of the housing area. And in Miami, they will be examining indoor monitoring of temperature and external monitoring of heat and other heat index variables. And in our last minute, I am just going to quickly mention that we did launch heat.gov on July 26th. It is a new website to provide the public and decision makers with clear, timely, and science-based information to understand and reduce the health risks of extreme heat. And it's a one-stop hub on heat and health for the nation and is a priority of President Biden's National Climate Task Force. And you can go to the next slide. And within this website, you'll be able to find climate information of temperatures happening right now, as well as projections. We also have information that you can find out how many people today are being impacted by heat, that people who are under advisories, heat warnings, heat watches. Next slide, please. And additionally, you can find more climate and health tools, such as the heat and health tracker that I mentioned at the beginning of the presentation, as well as the climate and health outlook, which pairs NOAA climate projections with heat impacts. Next slide. And also find out more information to learn about heat, as well as to access all of our urban heat island information, which was also previously mentioned. And also you can find information about compounding hazards too and linking to other resources as well, including NIDIS, some of our international partners, as well as other federal agencies. And with that, thank you so much for listening. If you're interested in heat and health, please visit heat.gov to learn more.
That was fantastic, Morgan. Thank you for that amazing overview of the situation of heat historically and looking into the future in the Southeast region and some really tangible activities. Hello, everyone. My name is Meredith Muth. I work at the National Integrated Drought Information System, NIDIS, part of NOAA. We co-organize this webinar with the Southeast Regional Climate Center and the National Weather Service. We've had a couple questions about getting access to these recordings, and an email again will be sent out shortly after this, maybe today or tomorrow, with key takeaways as well as the YouTube recording. If you have any questions right now, I know that we're almost at the top of the hour. Go ahead and list them, and maybe Morgan, if you could stay on for just a couple minutes, we'll see what we can get to. The next webinar we have is modernizing how you access water data. We talk about water data a lot in this webinar series, and so this is just going to give you a little bit of a tangible information on where you can find water data relevant to your location. And just a reminder that for those, when you close out this webinar, a quick little survey will come out. If you haven't taken it before, please do. It helps us improve this webinar series that's now been going on for 3 years. And any suggested topics that you'd like to hear about, please let us know. And I'm going to go ahead and just do a couple of questions before we wrap this up. These two are for Morgan. The first one is related to the study that you mentioned on redlining. And can you name or link that study?
Yes, I am putting that link in the chat right now.
I can do that for you, Morgan. I see that you have it up. I'd be happy to do that.
Perfect, thanks.
Okay, great. And I will go ahead and go to the next question. This is related to the urban heat mapping effort. And I've heard questions like this: why is my city not included? So for example, this one is, why was Memphis, Tennessee not part of the heat mapping as it is the largest city of Tennessee? So maybe you can say a few words about you know, why these cities are highlighted and opportunities maybe for future cities.
Yeah, absolutely. So our Urban Heat Island Mapping campaign is based on an application. So cities do have to put in an application to be able to partake in this program. And this past summer, you know, we had Knoxville and Nashville apply. Memphis, I do not believe applied, at least for this particular cohort. But again, if you are interested in seeing Memphis be part, we are hoping that the campaign application is going to be available later this fall, and would love to see, you know, more cities be able to participate.
That's great. And we will announce that call for applications through this Southeast Climate Webinar Network. So keep tuned out for it. We'll definitely highlight it. I think we're at the top of the hour, so we'll go ahead and wrap it up right now. Again, many thanks to all of our presenters and those of you who joined us today, and we look forward to coming together next month as well. Thank you.